7.5, inverse circular functions or inverse trig functions. I want you to understand the relationship between the sides of a right triangle and the angle. That's trig. That's what we're doing. And so when you first learned about it in geometry class, you said sine 30 degrees was opposite over hypotenuse. And that's 1. But then we talked about the chart. You said sine 30 was 1/2. It's the same thing. And you got kind of used to using the chart. That's great. All right? Or cosine 30, you're looking at adjacent over hypotenuse. And we said square root of 3 over 2. Or cosine 30 is square root of 2. All right? Now, when we do inverse trig functions, we just go backwards. Instead of me giving you the angle and you telling me the sides, I'll give you the sides and you tell me the angle. It's really still the same type deal. So when we look at the chart, I think that's probably where you should focus. When you see an inverse sine and a 1/2, you're going for the angle. That's going to be 30 degrees. Or inverse cosine square root of 3 over 2, almost same thing, 30 degrees. And if we're in, sometimes we're in radians and sometimes we're in degrees, but it works the same way. What you need to understand is an inverse trig function gives you that. If you only take one thing away from today's lesson, an inverse trig function gives you an angle. But we're still going to have to think about what and where. So the problem is, when I start giving you negatives, it kind of messes with your head a little bit because it's not quite the same thing. If I do an inverse sine of negative 1/2, your impulse and your gut tells you that that's negative 30 degrees. All right? But when I do an inverse cosine of negative square root of 3 over 2, your gut tells you the same thing. You're going to be right in the first case, but you're going to be wrong in the second case. All right? It's kind of weird. And so let's look at this. If I do inverse sine of negative 1/2, okay, inverse sine of negative 1/2 is negative 30. Okay, that's what we expected. Inverse cosine of negative square root of 3 over 2 gives me 150, which is not at all what I expected. Okay, it's not negative 30, and that's kind of a weird thing, and you've got to really, really pay attention. But that's where this chart comes in. So find in your notes packet, find this chart, and you're going to want to go back and look at it over and over again. I don't expect you to have this chart memorized, but you want to kind of have it in front of you. And you're looking at different things like domain and range. Keep in mind domain, think of domain as like inputs, and range is like output. Output is usually what your answer is going to be, or your angle. Notice this is in radians, which is okay, we can be in radians, but we've got all this different stuff, and this is kind of what we need to focus on. That's what your answers could possibly be. And I want you thinking about, can I even have a negative answer? When we talk about inverse functions, we're talking about something about the graph, all right? And technically, when we look at a sine wave, this is the function sine x. This function does not have an inverse as shown, okay? Because it's not 1 to 1. We're going to have to go way back to last semester and think about 1 to 1 is like the horizontal line test. Horizontal line test. This does not pass the horizontal line test, so it is not 1 to 1, and there's not an inverse. Likewise here. That's not really important for what we do. We don't have to have that information. But just understand that as a graph, it doesn't have an inverse. We're going to have to do something special. All right. The domain for this sine function looks like all the numbers, and the range looks like the line numbers go between -1 and +1. Same thing for the cosine function. But what we have to do is go to the graph, and what we want to do is, here's my sine function. I need to restrict the domain, right? Look at your chart, and notice that if I only look at this part of the sine function, as opposed to the whole thing, if I only look at this part of it, it will pass that horizontal line test. And so it does have an inverse if I only look at this piece of it. Kind of weird, but that's what it's saying in that chart, right? In this chart, it's saying if we only look between negative pi over 2 and positive pi over 2, it will have an inverse. Likewise, here's the cosine function. No inverse, but if we only look at this piece of it, it will have an inverse. Okay, so what we have to do is we have to restrict part of our graph in order to make it work. It's only going to go from 0 to pi. Look at this graph. It's only going to go from 0 to 3.14. It's only going to go from 0 to pi in order to make this work. All right. So we can get that. Here's our sine function. We're only looking at this piece, that domain, which is negative pi over 2 to positive pi over 2. And for the cosine graph, we're only looking at this part. And that means instead of all real numbers, it's going from 0 to pi. Kind of a weird thing to think about. That's what it is. That's what it is. The domain, we're talking about the input. The range, we're talking about the output. And so this part of this box is going to be really, really important to go back to. What I like to think about is whether or not I'm allowed to have negatives. So notice I see negatives here and here and here. That's going to be a big deal. It's also going to be a big deal to look at the quadrants. When we look at the unit circle, inverse sine of x, notice we're talking about negative pi over 2, positive pi over 2. But when you draw it out on the unit circle, negative pi over 2 is this angle right here. And positive pi over 2 is this angle right here. We're only talking about quadrants 1 and 4. Notice there's no such thing as quadrants 2 and 3. We're only talking about quadrants 1 and 4. And the reason why has to do with that graph that we restricted. If we're only looking at the sine curve, we're only looking at that restricted version from negative pi over 2 to positive pi over 2, then that means it only exists in quadrants 1 and 4. Kind of weird. You don't really have to know that by heart, but that's what's happening. Likewise, when we do inverse cosine, and we talk about from 0 to pi, well, 0 to pi is like this. It's only going to be defined in quadrants 1 and 2. Notice there is no 3 or 4. Kind of weird. That's how it is. So, when I do an inverse sine of negative 1/2, best thing that you can do, when you look at your chart, and you say, all right, we're doing the chart backwards, basically what we're doing. So we see a sine, and we see a 1/2, and we go backwards. Let's just do it in radians, so we see pi over 6. Your intuition tells you to make it negative. You see this negative, and like, let's just have the answer be negative, and that's not technically correct, because the negative has to do with where we are, right? The best thing that you can do is look at this chart and say, am I allowed to have a negative answer? Am I allowed negative? And in the case of inverse sine, you are, right? But then, when you do an inverse cosine, that next problem, you go here, and you see that same angle of pi over 6. And again, your intuition tells you to just stick a negative on there, but that's not how it works. Okay? How it's going to work is you look and you say, am I allowed to have a negative answer? You're not. The answer has to be between 0 and pi. It has to be a positive number. The way that we get that negative value is by the location. The negative value will be in the second quadrant. So when we talk about an inverse trig function, we're talking about an angle. We should draw that angle in the second quadrant. So if we have a pi over 6 in the second quadrant, we do what we've done before. And we say, well, this is pi, and get a common denominator, so that's 6 pi over 6. So this angle is right before 6 pi over 6. That must be 5. This is 5 pi over 6. Okay? Or, if you were in degrees, this would be like 30. We'd be 30 before 180, 150. And that's what our calculator told us before, right? That's why it was 150, was because it was in the second quadrant. A little bit tricky, but we'll get there. So, when we do inverse trig functions, you're looking at the sine and the 1, and okay, we do this and this, and it gives me, let's just stick in radians here. Pi over 2. If you don't have a negative, then it just is what it is. It's pi over 2. Same thing for the cosine. Inverse cosine of 0. You go here, we're going backwards. It's the same answer as pi over 2. It only ever gets tricky when there's a negative. That's when you have to think about stuff a little bit now. All right? So, inverse tangent of -1. Inverse tangent of -1. We go here, we go here, we go here. And, people want to say it's negative pi/4, but really what you should do is you should go into this chart and ask yourself, am I allowed to have a negative answer? Okay? And this says we are. And so if you're allowed to have a negative answer, it's negative. The end. There's nothing tricky about it. If you're allowed to have a negative, it's going to be negative. Okay? Inverse cosine of -1/2. Inverse cosine of -1/2. So we go to the chart, we go here, and we go here, and we see this angle, pi over 3. But we need to ask ourselves the question, are we allowed to have a negative answer? And in this case, we're not. Okay? We are not allowed to have a negative answer. The way you get this negative is from the location. And this is telling me that that location is in the second quadrant. So what we have to do is we have to think about a pi over 3 in the second quadrant. There is no third or fourth. There's no such thing. All right? A pi over 3 in the second quadrant here. So that's pi. We'll call it 3 pi over 3. So this angle is right before that. This must be 2 pi over 3. 2 pi over 3. Okay? Next one, inverse sine. Am I allowed to have a negative answer for this one? For inverse sine, I'm allowed to have a negative answer. And so when we use the chart, all I have to do is just say -5/4. So what's tricky sometimes is you get on a roll and you just look at your chart, you just keep going and you're cranking it out. And most of the time you're going to be fine until you run into one where you're not allowed to have a negative answer. You got to think about it, right? So inverse sine of 1.5, that's obviously not in the chart. So when it's not in the chart, that means it's a calculated question. Okay? And so your calculator might work a little bit different than mine on this, but if I did inverse sine of 1.5, you should try it on your own and see what happens. But mine gives you this really weird looking thing. Notice there's a letter I on the end of it, imaginary. It's not going to work. It's not a real number. It's not an answer. Your calculator is probably going to give you an error. It doesn't work, okay? And the reason why it doesn't work, you got to look back at the chart again, okay? You should probably also ask yourself the question. Am I even allowed to use that number? That's the domain. Remember, the domain is the input. And for an inverse sine, we're only allowed to plug in numbers between -1 and +1. 1.5 isn't going to work. 1.5 is not going to work. So this one is undefined. Technically, you should be asking yourself that every time. All right? Next one, inverse cosine of -0.436. Am I allowed to plug in -0.436? Yeah. I'm allowed to plug in anything between -1 and 1. That's what that domain says. Am I going to get a negative number? Okay. I'm not going to get a negative number. Can't get a negative number. So when you plug that into your calculator, let's put it in radians here. Radians. Inverse cosine of -0.436. 2.02. I'm changing whatever I want. Like the symbols. 2.02 is kind of a weird thing. It's hard to understand what that means. If you put it in degrees, maybe that makes it easier to understand. 115.8 degrees. Okay, we can see that that's in the second quadrant. That's in the second quadrant. And that's what it has to be, because that's how you're getting this negative value there, right? It has to be in the second quadrant in order to get that negative. So look at the, look at what was the radian value was 2.02, let's say 2.0219. 2.0219. And you have to round off later. I like 4. If it doesn't say anything else, I like 4. But if you think about how to draw that, we know up top is pi over 2, which is about 1.57. And over to the left is pi, which we know is about 3.14. So as we go around the unit circle, 2.02 is going to be somewhere after 1.57. And it's 4, 3.14. That's in the second. Next one, inverse tangent of -1.5. Am I allowed to plug in -1.5? Yeah, because I can do anything. The domain for inverse tangent is all those numbers, meaning I plug in anything I want. And so let's put in radians, inverse tangent, -1.5, -0.9828. Am I allowed to have a negative answer? This one I am. Inverse secant of -2. Inverse secant of -2. Am I allowed to plug in -2? Or this one? This one's crazy. Basically, that's like almost the opposite of your cosine. Right? It says everything else. We don't want -1 to 1. We want everything else. Everything else. And so -2 is going to fit in somewhere in here, right? In between -infinity and -1. So that's going to be fine. It's going to work. Okay? This is actually a no calculator question. You should be able to do this without a calculator. And what I would do is I would switch it around. I would take the reciprocal and treat it like this. That's an inverse cosine of -1/2. And so I can go here, and here, and here. Am I allowed to have a negative pi over 3? Am I allowed to have a negative answer? I'm not allowed to have a negative answer. How I have to deal with that is I have to stick it in that second quadrant here. Okay? So we stick it in the second quadrant. We've got a pi over 3 reference angle in the second quadrant. This is pi, 3 pi over 3, meaning this must be 2 pi over 3. Okay? That last one on there is also a no calculator question. All right? It's also a no calculator question. And if you dealt with it the exact same way, going to say the reciprocal is going to be sine, so inverse sine of whatever that reciprocal is. So if I take that reciprocal and rationalize, square root of 3 is 3, and that cancels out. Really what I've got is this. That reciprocal turns into negative square root of 3 over 2, which is awesome. That's in the chart. That's in the chart. Is thinking. So where are we at? Here and here, here again, over 3. Am I allowed to have a negative answer for this one? Yeah. So all I have to do is say that's negative pi over 3. If you're allowed to have a negative answer, you just stick a negative and go. If you're not allowed to have a negative answer, you got to draw it out and think about where it is and what happens. All right? It gets really hard because sometimes it's fine and sometimes it's not. You have to really pay attention to this chart. So again, an inverse trig function is an angle. All right? If you don't learn anything else today, learn that. An inverse trig function is an angle. Because we get to these problems and people kind of flip out because they think it's super hard. All right? And if you don't understand that an inverse trig function is an angle, this is going to be next to impossible. But if you understand that an inverse trig function is an angle, these are kind of fun, I think. Okay? Here's what I would do. I know that since this is an inverse trig function, it's an angle, so I'm just going to call it theta. Inverse trig function is an angle, that's theta. I should be able to draw a picture of that angle. Okay? So since we're talking about an inverse tangent function, it can only be defined in either quadrant 1 or 4. But since this is a positive fraction here, I know that it has to be in quadrant 1. We are definitely in quadrant 1. So I can draw a picture of theta in quadrant 1. Remember, when you draw your triangle, it has to touch a coordinate. Okay? So the tangent ratio is given to us, and we know that's y over x, or you can think of it as opposite over adjacent if you want to, but we've got this ratio, y over x, 3 over 4. We can do Pythagorean theorem to find the missing side. You should get pretty good at this. This is a 3, 4, 5. You see a 3, 4, 5 all the time. I've got that triangle in the first quadrant. So go back to your equation. If you think about it, all we have, the problem says sine of an angle. So look at your picture. Sine of that angle, remember sine is y over r, right? Y and r. This answer is 3/5. If you understand that an inverse trig function is an angle, it's pretty quick. So again, inverse trig function is an angle. You gotta know that. Can anybody tell me what quadrant I'm in? What quadrant must that angle be in? Not 2. Inverse sine is only defined in these 2. It's got to be in the 4th because that's how we get our negative value. My angle is in the 4th quadrant, so I can draw a picture of that angle in the 4th quadrant. The sine ratio is y over r, or opposite over hypotenuse if you want. Y over r, like this. That one's not a well-known triangle, so maybe I'll just go ahead and do my Pythagorean theorem. Right? If you don't know it in your head, you're not going to Pythagorean theorem, I suppose. X squared plus negative 2 squared equals 5 squared. X squared plus 4 equals 25. Subtract that over, so x squared equals 21. X squared both sides, plus or minus square root of 21. But we're talking about an x number after all, and our x number in the 4th quadrant has to be positive square root of 21. Good? That's our picture. That's our angle. But if we look at it, at the problem, all we're trying to find is cosine of that angle. And so you look at the picture, and all you have to do is say cosine of that angle, x over r, square root of 21 over 5. Now, bad ones you get the picture on. So one more of those, and then we'll step it up a little bit. Same thing, this is an angle. Inverse trig function is an angle. What quadrant is that angle in? It's got to be in the second quadrant. That's where your inverse cosine function is negative. There is no 3 or 4, no such thing, because I had to restrict the domain or whatever. Okay? It's got to be in the second quadrant. So I can draw a picture of this in the second quadrant. Cosine is x over r, so that's negative 3 and 5. Okay? This is 3, 4, 5. You should know what 3, 4, 5. Okay. 5 has to be the hypotenuse, but that's a 3, 4, 5. Okay? So if that's my picture, I'm just trying to find tangent of that angle. Tangent is y over x. Tangent is y over x. Or opposite over adjacent if you want to do it that way. But regardless, I'm going to get negative 4x. I like those problems. I think they're kind of fun. Okay, let's kick it up a notch. We get to this, and I got a little bitty typo in here. That's supposed to be inverse tangent. Okay. So this one looks really insanely difficult, but again, just keep in mind, you know what an inverse trig function is. An inverse trig function is an angle. But the thing is here, I've got 2 different inverse trig functions, so I'm going to have 2 different angles. I'm going to call this one A and this one B. I've got 2 different inverse trig functions, so I've got 2 different angles. I draw a picture of A. What quadrant does angle A have to be in? Right, if this is positive, we know we're in quadrant 1. So I can draw a picture of angle A in quadrant 1. So the cosine ratio is x over r. So that's going to be x r, that means this is 4. Okay, I'll hold up on that, I'm going to look at my other picture. Angle B is a different picture, it's a different angle. So what quadrant must I be in? It's got to be in 4, because this is negative, right? That's negative in quadrant 4. So I can draw a picture of angle B in quadrant 4. So my tangent ratio, I know tangent is y over x. So that's y is x. Okay. And you should probably know a 5, 12, 13 just as well as a 3, 4, 5. 5, 12, 13 happens all the time. 3, 4, 5 happens all the time. Those are my 2 angles. Okay? So go back and look at your problem. Your problem says this, sine A plus B. And when you see that, that should remind you of all those formulas that I wrote on the board. All right, that looks like one of our formulas. Sine A plus B is one of our formulas. You should be prompted to look it up, right? Specifically, it looks like this one. Sine A plus B, that's one of our formulas. And so I'm going to change my formula into that other side of the equation. Sine, cosine, plus cosine, sine. Sine, cosine, plus cosine, sine. Or poles to fill. Sine A, I can just get from the picture. Your sine is y over r. So sine A, y over r, let's focus. Cosine B, you got to look at the other picture. The B picture. Cosine is x over r. So that's x over r, it's 5/13. Switch back to the A picture for cosine, that's x over r, right? The x over r ratio for cosine, that's going to be 3/5. And sine B, switch back to the other picture, sine is y over r, sine is y over r, negative 12 over 15. All that's left is just to clean up the fraction. You got 20 over 65 plus negative 36 over 65 is negative 16 over 65. really fun. Type it. You can draw those pictures. Happens. One more. Okay, one more. Just trying to show you that they're all pretty much the same. Doesn't matter how hard it looks. They're all pretty much the same, and they all hinge on this knowledge that an inverse trig function is an angle. If you don't know that an inverse trig function is an angle, then you're going to have a hard time. What quadrant must that angle be in? It's got to be in the second quadrant. Because we're looking at inverse cosine, looking here. In order to get that negative value, it's got to be in quadrant 2. Okay? We have an angle in quadrant 2. Make sure you draw your triangle correctly. It's got to be touching the word. The cosine ratio is x over r, so that means x and r right there. That's not a well-known triangle, so I'm going to need to do factor in x squared plus y squared equals r squared, or 1 plus y squared equals 16. Subtract over, you get 15. Y equals plus or minus square root of 15. But since we're in quadrant 2, we know that's got to be a positive square root of 15. So we look back at our problem, and it says sine 2 theta. Notice we don't have a picture of 2 theta. You can't look at the picture and just get 2 theta. Also, you can't just multiply by 2. That's not how it works. What you have to notice is this is one of our formulas. You have to say, this is one of our patterns on the board. This is one of the things on my formula sheet. Sine 2 theta. Didn't find it. It's one of the double angles. It's this one. Okay. So I'm going to change it to this. I don't really want to be looking at 2a. I want to be looking at just regular old a's, because that's what I drew a picture of. I drew a picture of regular a's. This formula is 2 sine theta cosine theta. So 2 times this. So we look at our picture, and we know sine is y, or y over r. This over this is square root of 15 over 4. And we know cosine is x over r. So that's x to r negative 1/4. So multiply that all out, and you get negative 2 square root of 15 over 16. Looks like we can reduce the fraction. 2 goes into 16. Negative square root of 15 over 4. Now, I tried really hard to shorten the notes. I know there's a longer version of the notes out there. If you want more details, you want more exercises, more examples, check it out. Check out the longer video. That's fine. I'm hoping you can understand better from the shortened version.
So you did post videos, so?
Yeah, the notes is completely on Schoology already, but I got the long version. I'm hoping if this turns out well, I'm going to post the short version.